Hello! Alright, so the purpose of this video is to show you how to identify solutions to two equations by graphing. Okay? So if you guys remember this problem that we went over in class, or well, it was that one particular group anyway, but dealt with Thin Mint boxes and cookie corner boxes. So this is our system equations, and one way I show you in my solutions is basically this is one way that you can solve for x and y by using that method called substitution. Okay, so what if now, like let's say we didn't want to solve it by substitution or elimination. What if you wanted to graph it instead? You could totally graph it as well. So I'm going to go ahead and just minimize this. I'm going to go into, so if you don't know what I'm going to type in, I'm going to put desmos.com/calculator. desmos.com/calculator. So type that website in, and here we go. Okay, so we're going to take that exact same equation to what we have here. So we have x plus y equals 250. So I'm going to type that in, x plus y equals 250. And then I'm going to graph the other one, 4x plus 19y equals 1990. Okay, 4x plus 19y equals 1990. All right, so let's go ahead and zoom out, but we cannot see where we are. Oh, there we go. You see the red line and the blue line. So basically, the key idea behind this is wherever the two graphs intersect, that will give us the number of solutions for this problem. So as you see, as we zoom farther and farther out, they only intersect at one point, and that one point just happens to be at 184, 66. And that's exactly what we got here when we use substitution, 184 and 66. So yeah, pretty cool. You could graph this using Desmos, and you can solve the problem that way if you wanted to. Okay, let's say give another example. So let's say I were to just change this up. Let's say I give you y equals 2x minus 7, and then I change this to something like 3x plus 4y equals 16. Okay, so now let's say I ask you like, oh, how many solutions does the system equations have? So if I were to kind of scroll all the way into here, I just click on this point. Basically, these two lines, the red and the blue, they both intersect only at one point. So there's only one solution. And basically that one solution would be at 4, 1. Okay? Let's say I give you another example. So I gave you something like, let's see, 4x plus y equals 6. And I give you another example, something like 12x plus 3y equals 18. Okay, so let's try to look at this here. So as you see, the blue and the red curve just kind of overlap right on top of each other. So that means no matter where we come down on this blue line is basically the same as the red. So what this means is that basically the two lines intersect everywhere. So in other words, this is a case where you have infinitely many solutions. Infinitely many solutions. So basically there's, a lot of solutions to this particular problem. No matter what x you put in, let's say this x is 1, and then this y has to be 2, right? So if I plug in 1 into here, so 12 times 1 is 12, and then 3 plus 2 is 6, 12 plus 6 is 18. So no matter what x and y you plug into here, as long as it fits this equation, it's going to fit the other one as well. So that's basically how infinitely many solutions works. Okay, let's say I give another one. Y equals negative 4x plus 6. And I give you something like y equals negative 4x plus 10. Okay, so now let's zoom in to here. So if you guys don't remember what this is called, these are called parallel lines. So it may be a little geometry concept that you may have forgotten, but basically whenever you have a case where the lines are parallel, basically there's no point of intersection for these graphs. You see, as we zoom out, it looks like they're getting closer and closer, but they're not. They're always going to be parallel with each other. So in other words, there is no solution for this particular problem because the lines will never intersect with each other. Okay? Now, let's play around with this a little bit more. Okay, let's say I were to just call this red function, let's say I just call it f of x. So y is the same thing as f of x. And let's say we call our second function, let's call it a different name. Let's call it g of x. So y is also the same as g of x. So as you see, basically the problem isn't changed. Basically, we can still graph it this way, but we're just using different notation. We're using f of x and g of x, basically what you can see there. Okay, let's say I were to modify this. So let's say I put something like 4x minus 7, and I gave you something like g of x is equal to negative 5x plus 11. Okay, so if I were to look at both of these graphs here, so you see here, if I were to click on that point, that basically tells me what x would be. So in other words, so earlier we had y equals 4x minus 7, and with y equals negative 5x plus 11. So basically, if we were to set f of x and g of x, so our two functions, if we set them equal to each other, we can find the solution for this problem. So in other words, we can solve for x. So when we solve for x here, so basically x is 2, and then supposedly if we were to go ahead and solve for y, no matter what equation we plug it back into, y is going to be 1. So that's how that one works. Let's say I change it up. Let's say I gave you something like this. Let's say I gave you something like 2x plus 11, and I gave you something like negative 11x minus 15. Okay? So if I come here, if I look here, so again, there's one point of intersection, and that one point of intersection, no matter how far I go out, this one point of intersection is going to be at negative 2, comma 7. So negative 2, comma 7 would be our solution to this problem if we were to set this equation f of x and g of x to each other. Because just think about it, this is the same thing as y equals 2x plus 11, and the same thing as y equals negative 11x minus 15. Nothing changes. So we're just writing it in a different notation, as you can see. Okay? Let's say I gave you another problem. So let's say I gave you something like this. So f of x equals negative 4x, and then g of x equals something like 6x plus 20. Okay, so as you can see here, again, if I zoom out, zoom back in, if I click here, there's only one solution, and that solution to this particular problem is going to be at negative 2, comma 8. Okay, now what if I were to change this up? What if I were to change this up? Now let's say I put something like 2x minus 3, and this is going to be something like 2x plus 6. So, same idea. If we set f of x and g of x equal to each other, the interesting that's going to happen is, if you see, these lines are parallel. So since these lines are parallel to each other, basically we're going to have no solution for this problem. So basically what that means, we cannot even solve for x. Okay. All right. So I'm going to stop the video here. I'm going to go over a few more cases, and I'll see you soon. Okay, bye. Alright, so let's go over a few more different cases. Okay, so let's say I gave you something like this. So f of x, now, let's say I give you something like x squared. So if you don't know how to do the square, so if you see how I put x squared here. If you don't know how to do that, you press shift 6. Shift 6 gives you the caret, and that's how can you get the square. Okay, so we have f of x equals x squared, and let's go ahead and change it. Let's go ahead and change it to 4x. 4x minus 4. Okay, so now if you look at this, try to guess how many solutions we have. Now if we zoom in, so if we zoom all the way in, it actually looks like the blue graph, the line is just barely touching the parabola. So basically, if I were to, okay, a little bit too far, let's say we were to zoom back out here, that looks like our solution. It's going to be at 2, 4. So basically, for this particular problem, we're going to have one solution for this. It's going to be at the coordinates 2, 4. Okay. Let's say we were to change this up a bit now. So let's say I were to change this. So instead of 4x minus 4, let's say I gave you something like negative 2x plus 8. Okay. Now, this is where it gets a little bit interesting. Now, if we look at the graph, I want you to think, well, now how many solutions do we have now? And if you look at, so in order to find the number of solutions, basically you're just looking at where the red curve and the blue line basically cross each other. So as you can see, they cross at 4 comma negative 4 comma 16, and it looks like at the other point they cross, it's going to be at 2 comma 4. Okay, I can see some of you getting confused if you guys try to think, oh, maybe that's like in here, maybe that's the intersection, there are not intersection points. Okay, so what Desmos does is this is basically your y-intercept, and this right here is your x-intercept. So if you're only considering solutions to the equations, you're only looking at where the red curve and the blue line basically cross. Do not look at the x or y axis for solutions. It's just here and here. So that's what you can see. Okay? All right, so let's go ahead and show you another example. Let's say change this up. So I'm just going to put 2x, I'm going to 2x squared, so shift 6 again, so shift 6, that gives you the exponent, so 2x squared, and then I graph something like x plus 6, okay? So if I look at this now, try to guess how many solutions we have. Again, only look at where the red and the red curve and the blue line intersect each other. So in this case, basically our solution is going to be, our two solutions to the particular example is going to be negative 1.5 and 4.5 and negative 2.8. So that would be our solutions to that one. Okay. All right. So let's go for the last example. Last example is kind of interesting. Okay. Let's go ahead and change this up a bit. Okay. So what I'm going to introduce you to is I'm going to introduce you to this idea of a circle. So the equation of a circle looks something like this. So it's basically x squared minus x squared plus y squared equals some constant. So in this case, let's just say it's 10. Okay. So, and then let's say we make our other one. Let's say we make our other equation. We're going to make this y equals 3x. Oh, it's not going. Yeah, y equals 3x. So something like this. Okay. So what we have is we have a circle, and now we have a line. Okay, so let me just give you some little information about how a circle works. Okay, let's go ahead and just get rid of this blue line for now. Okay, so the equation of a circle that's basically centered at the origin. The center is at the origin here, which is 0, 0. The way that this circle is graphed is basically there's a formula for a circle. So it goes x squared plus y squared equals r squared. So r would be the radius. So basically, if I put this here, let's say I put square root. Oh gosh, okay. So 10 goes in here, and then basically, if I put parentheses here and here, that basically gives you the exact same thing that I showed you earlier. Like if I just showed you like x squared plus y squared equals 10. So you see, the green just goes over the red, as you can see. So it's the same thing. Yeah, so if you guys are curious, let's say we took the square root of 10. So square root of 10 is going to be 3.1622. So what that means is, let's say from the origin here, we go out that distance. So that means the point here is supposedly going to be at 3.1622. I'll just leave it at comma 0. And another point is going to be at negative 3.1622, comma 0. So as you can see here, if we go straight out from the origin, basically we're going the radius, or in other words, the square root of 10. Yeah, so it's basically the radius of this circle. So it comes out like this, it comes out like that. And basically, again, what I mentioned, if you see it, anything of the form x squared plus y squared, basically that will indicate that it's going to be, you're creating a circle that is centered at the origin, or in other words, 0, 0. Okay, anyway, let's just go ahead and I'll go back to the problem. Just wanted to give you a little bit here. I'm just going to change this up. This is just 10. Okay, so, and then we have this. Okay, so basically what we have is, if we want to just identify how many solutions we have 2 solutions. So we look at the circle, you see the red circle here, and then we look at the blue line. So these are two solutions to the problem. So it's going to be at 1 comma 3 and -1 comma -3. All right. So that's basically it on identifying solutions when you have two particular equations. Okay. So if you're wondering for your assignment, what you're going to do is basically just straight up identify how many. If I give you something like this or this, you just got to tell me how many solutions you have. It's a very easy assignment. Okay. Let me know if you have any questions on this, and that's it. Okay. Bye.